What's up? What's up, guys? So, this video, let's compute this. Okay, so we may have a more general video that we can compute more. So in the previous I think in the previous video that we encountered this, right? So this one we can encounter much x to the fourth, and then in the future we may compute other more. Right. By the way, if you can use compute gamma, you can use a gamma function to compute it if you know about this. Right, but this is a complex analysis section, so we only use a complex analysis. Okay, so this is very easy. I don't waste you guys' time. So, by the way, subscribe to my channel. Okay, so let's only consider the semicircle. Right, so we can take a semicircle as this. Okay, and then take R to be infinity. Okay, so this is C1, this is C2. Okay, so and also you have two poles. Okay, so let's maybe write down everything. So we have C1, f of z defined to be 1 over 1 plus z to the fourth. So it's f of z dz plus C1 plus C2. F of z dz equals to 2 pi I residue the semicircle at the f of z. Right. So okay. So now we know that when r goes to infinity, and the C2 part will disappear, and the reason is that let me just first say, okay, so C2 f of z dz is basically, let's say z equals to r exponential I theta, so you get this. So this will less or equal to r to the fourth, right? We can take this, and dz is r to the 3, right? So that's d theta. Right, so this term goes to 0 as r goes to infinity. Okay. So C2 is not important. So we know the answer. So the answer is that this C1 integration will be equals to this. Okay. And then when r goes to infinity, the C1 will just become what the interval we want to prove. So finally, our answer will be this. Answer will be 2 pi I residue f of z upper half plane. Okay, so that's how many. So let's solve the pole. So solve the pole. Okay, so pole comes from 1 plus z to the 4 is 0. So z to the 4 is minus 1, which is exponential I pi. Okay, so the n, or you can plus 2 pi I n. Okay, so z will be exponential I pi divided by 4 plus pi I n divided by 2, and the n is 0, 1, 2, 3. Okay. So when n equals 0, you get the exponential I pi divided by 4. When n equals to 2, you get n equals to 1, you get I pi divided by 3. 3 pi I divided by 3. So these two are upper half plane pole. Upper half plane pole. Okay, so our answer will be just need to consider these two. Okay, so will be 2 pi I exponential I pi divided by 4, the residue, plus residue exponential I pi 3 divided by 4. Okay, so what is the residue of f of z at z equals to exponential I pi divided by 4? Okay, so this is just easy, right? Since that we know, so we can use the so-called residue formula. Right, so since it's a single pole, so we can just write that times z is minus exponential I pi divided by 4, and take the limit. Okay, so you can use the L'Hopital rule. You get z approach to exponential I pi divided by 4, 1 over 4z to the cube. So it's 1 over 4 exponential minus I 3 divided by 4 pi. Okay, and the same as z equals to exponential 3 pi I divided by 4. You just start from here, so you get 1 over 4 exponential minus I 9 divided by 4 pi. So just add these two. Just add these two. So just add these times 2 pi I and add these two. Okay, so this is our answer. Okay, so elementary computation gives you pi over square root of 2. Let's see. Okay, see you guys in the next video. Subscribe to my channel. Thanks.